Let's deal with them tan lines. You got the tangent line stuff down now pretty well? I hope so. I keep bringing it back in over and over. Well, your text does, and I kind of follow along. But let's look at it. Just one problem in this one. It'll be enough. We want to find all points for x squared plus xy plus y squared equals 4, such that the tangent lines are horizontal. Tangent lines are horizontal. That's aka dy dx equals 0. Cool? That's what it means. Horizontal tan lines. That means anywhere you see a dy dx, you just lose that term. Whatever's being multiplied by. Just goes well. Sounds like a mellow problem. We're only doing this one. Huh, good shit. So let's write our stuff down. So x squared plus xy plus y squared is equal to 4. Now this one's mellow. So we'll take the derivative on x squared. We get 2x. And then we got to go do that product, the x and the y. So that's 1, that's dy dx. So what do we get? X times dy dx plus 1 times y, or y. Next we move to the y squared. The 2 falls to the front, so we get 2y times dy dx is equal to, derivative of 4 is 0. As I said before, if we're looking for horizontal tangent lines, that means that dy dx is equal to 0. So these are just going to go away. And the only thing we're left with is 2x plus y is equal to 0. Oops. 2x plus y is equal to 0. We solve for y, we get that y is equal to negative 2x. Sweet. So what's the point? What is it, x equals 1 and then y equals negative 2? Is it x equals 0 and then y equals 0? Which one is it? How are we going to solve for this? There's infinitely many answers to y equals negative 2x. Dude, I wish there was some other formula we could use to plug it into, because when you have 2 variables and only 1 equation, good luck solving for it. But if you had 2 equations, like what was given to you at the beginning of the frickin' problem, and what we just found out, I think we could actually go and take this negative 2x and pop it in everywhere we see a y. I think we could. So let's write that. X squared plus x times, and I'm not going to write y, plus y squared is equal to 4. Let's take this and pop it on in. Negative 2x and negative 2x. Now everything's in terms of x's. We can go solve for x. Let's get it. From algebra, so we get x squared, and what's this? This is x times negative 2, that's negative 2x squared. And then this one is negative 2x all squared, that's positive 4x squared is equal to 4. And what's that? 1 minus 2 is negative 1, so that's 3x squared is equal to 4. Let's divide the 3 over. And when we hit that thing with the square root, we're going to get that it's x is equal to plus or minus the square root of 4 over, 4/3, my bad. Square root of 4 over 3, so we get plus or minus 2 over root 3. So we found our x values, but this question does not ask you for x values. It is asking you for y values, so it asks you for the points as well. Well, it asks you for the y values as well. So we had 2 root 3, and then we got to go find our y. And we got negative 2 over root 3, and we got to go find that y. So we need to take this and plug it right back into the original equation, or why didn't you just put it into this little substitution? So we can say that, all right, well, when x is equal to 2 over root 3, our y value is equal to negative 2 times 2 root 3, or negative 4 root 3. It looks like it just changes the sign and multiplies it by 2. And when x is equal to negative 2 over root 3, we can say that y is equal to negative 2 times negative 2 all over that root 3, 4, positive 4 over root 3. And there we be. There are our, well, I don't know what I just wrote there. There it is. There's our solution, our 2 different points, such that the tangent lines are horizontal, both the x and the y. So when you take a derivative, you're going to set that thing equal to 0, then solve. That's where the tangent lines are horizontal. Cool. The next one, we're going to start introducing inverse trigonometric functions. I love this stuff. We're going to have 6 new derivatives, and we're going to use implicit to show it. See ya.